All right, so you've seen similar trip travel where we have two planes that went in the same direction, just at different speeds, and they had the same distance. So my blue D ended up equaling my purple D, and then if I remember correctly, distance equals rate times time, so I could set those equal to each other and solve for either my rate or my time that I wanted to know. Those equations generally looked something like D equals D, and then I would substitute in my rate times time for D equals my rate times time for my blue D, and then solve and get everything in terms of one variable or the other. Those were similar direction travel. Round trip travel is very similar to this, as you're going to see. So let's look at this program, or I'm sorry, this example. Noya is driving into the city to buy a software program at a computer store. All right, so she's leaving her home and she's driving into the city to get her computer program. But because of traffic conditions, she averages only 15 miles an hour. That's really painfully slow. Now on her drive home, she averages 35 miles an hour. So she manages to make it home way faster than she made it there. On the return trip, since she averaged 35 miles an hour, on the return trip, she averaged 35 miles an hour. She made it home way faster. She traveled the same distance. The store and the house did not change. And I know that my total travel time up here is 2 hours. And I want to know how long does it take her to get from her home from the computer store. So let's set this up and draw this out. I always find it helpful to draw a diagram. So I'm going to look at the time that she left her house to go to the store. Now, whatever this distance is, it doesn't change. But I know that it equals rate times time, and I know that my rate here was how long? Well, here it's only 15 miles an hour. It's so painfully slow. And I know on the drive home, when I went here, still the same distance. It didn't change. And it still equals rate times time. And I know that my rate here is 35 miles per hour. Okay, so it's a lot faster. I'm going to get home way faster than it took me getting there. Now, I want to make a chart. So on your own paper, let's start making a chart. Write this out with me. So my chart should have rate, it should have time, and it should have distance. And I've got my two different variables. I have the time that I left and the time that I came back. So I like to use colors for these. I recommend that you do too. So let's say trip 1 and trip 2, her return trip. Okay, so the first time she left, her rate was 15, and it's some time. And the distance is going to be something like 15 times t, because it's my rate times my time. Now I come down to trip 2, and I have 35, and I have green t. Notice that these are going to be different times. We're going to get to that in a minute. And I know that my distance is still going to be rate, which is 35 times t. Oh, but my yellow t and my green t are not the same time, so I need to put these in terms of each other. Let's look back up here. Do I know anything about time? Oh, my total travel time. My total travel time is 2 hours. How do I express that? Well, if my total time is 2 hours, it's my yellow time, the time that it took me to get there, took some portion of that, and the time it took me to come back was some part of that, and together it equals 2 hours. Okay, so let's use my initial trip, and let's just say I want to get one of my t's away. So I'm going to subtract t from this side, and I'm going to subtract t from this side, and I'm going to get t equals 2 hours minus green tea. Okay, so everywhere I have yellow tea up here, I'm going to come in and plug this in. So t equals 2, this is in hours, minus t. All right, so I plugged it in up there. I still need to come over here and plug it in for my distance. This equals 15 times, what does my yellow t equal? Well, it's this thing right here. 2 minus t. All right, let's come down here and let's look at solving this. Make sure you have this chart on your own paper. All right, let's look up here. Remember that to solve similar travels where my distances are the same, I can set my distances equal to each other from trip 1 and trip 2, and then I plug in my rate and time and solve for those variables. So if I'm back down here looking at this, the distance from my house to the store and from the store back to my house should be the same amount of distance. It's the same number of miles. It doesn't change. What changed was the speed with which I went, the 15 and the 35, and if my speed changes, then my time is going to end up changing. But this distance is the same as this distance. So how do we solve this? Hopefully you said put my distances equal to each other. So here I've got distance that's yellow. That's my yellow trip. It's my first one. And I'm going to set that equal to my return trip because I know that the distance is the same number of miles. Distance is always length of some sort. Okay, now what do I know about my d's? Well, if I come back up here, I know that my distance that's yellow is in this box right here. Remember, distance is always rate times time, and my rate is 15, and I'm multiplying it by time. And my time I expressed in relationship to my green tea. So it's 2 minus t equals, well, what's my green rate? It's rate times time on this side of my equation too. So my rate here was 35. And I've got to multiply it by my time. Oh, I don't know it. It's just t. All right, I only have one variable. They're both my green t's. So first, what are my 5 steps for solving equations? The first thing is always to clear fractions and decimals. The second is to deal with the distributive property. I have distributive property here. So I have 15 times 2. Write it out, guys. Make sure you put this down on your paper. I want to see these notes. Minus 15 times t. You could have also written this as plus 15 minus times a negative t. And this equals 35t. All right, let's reduce and simplify this a little bit. I've got 30 minus 15t equals 35t. Okay, so far the algebra is solid. What do I need to do next? Right, I've got to subtract my 30. If this is a positive 30 over here, then I need to undo it and get it moved to this side of my equation. So the opposite of addition is subtraction. So I have positive 30 plus a negative 30 minus 15t equals 35t. And what I do on this side over here, remember I just subtracted this 30, I've got to also do it over here. All right, so now I have negative 15t equals 35t minus 30. All right, I'm not done yet. I've got to combine like terms. My 35t and my 15t need to be combined because they're both t's. So I've got to subtract my 35t minus 35t. Remember to bring down your minus 30. And we're going to set that equal to negative 15t plus a negative 35t. Okay, my 35t and my negative 35t cross out because there's 0t, and 0t is just 0. So I have negative 30 equals negative 15t plus negative 35t should hopefully give me negative 50t. Okay, now I've got to divide by negative 50 so I can get my t by itself. And what do you end up with? Make sure to simplify. Hopefully your answer ended up looking like t equals positive 3/5. Because remember that two negatives divided by each other equal a positive. So 3/5 of an hour. That's my yellow t. Well, let's come back up here to my question and see what it's asking. I want to know, how long does it take me to drive to the computer store? Which trip was to the computer store? Well, that's this one right here when I first left. That's my yellow t. And I just told you that t equals 3/5. But is that my original t? No, because I sat in traffic. So let's come back up here and look at my chart. If I'm up here looking at my chart, here I've got, if I look at trip 1, it took me 15 miles an hour, and this was my time. So the time for trip 1 is t equals 2 hours minus t. So I now need to plug in my 3/5 from over here because that was my faster time. That's the return time. I know that this t is 3/5 of an hour. So the original time that it took, my yellow t, is going to be 2 minus 3/5. All right, how do you subtract fractions? Remember that to do this, I'm going to have to turn 2 into some sort of a fraction, and 2 over 1 isn't going to do it. Ruh-roh, I've got to make common denominators. So this equals 10/5 minus 3/5, which gives me how many fifths? T equals 7/5 of an hour. Make sure to simplify all the way. This is improper. I can't leave it improper. So t should hopefully equal 1 2/5 of an hour. Let's think about this a little bit. I've got a whole hour. How many minutes do I have? What is 2/5 of 60 minutes? Hopefully it's 24. I just took 2/5 of 60 minutes. So I have 1 hour and 24 minutes. That's how long it took me to get to the original store. How long did it take me on my return? Well, if I come back up here, t equaled 3/5, and it was 3/5 of an hour. Anytime you see of, it's multiplication. So let's figure out how many minutes. 3/5 times, I got that from my of, an hour. How many minutes are in an hour? 60 minutes in 1 hour. All right, let's cross multiply. 5 goes into 5 one time, 5 goes into 60 12 times. Now I can multiply 3 times 12 and get 36. So it took me 36 minutes to get home. It's a huge difference. So now let's come over here and let's summarize what we've just done. Let's write a new table. We have rate, time, and distance, and that's for trip 1 and for trip 2. Now let's plug in what we learned so far, just to kind of summarize and make sure we found everything. Okay, so my rate for my first trip was 15 miles per hour, and the time that I did it in, I said was 1 2/5 hours, also known as an hour and 24 minutes. And my distance, well, I don't know what my distance is. I haven't found that yet. But I do know that I can find distance as rate times time. So let's do that really fast. My distance equals 15 miles per hour times 1 2/5 hours. Notice that my units here are going to end up crossing out, so I'm going to get just miles. I'm going to show you that here in a second. First, I need to get my fraction over here improper so I can multiply more easily. So this becomes 7/5, and it's hours. Notice that just like I would cross out other things, like numbers, my units end up crossing out because hours divided by hours end up leaving me with just miles. So my distance is 15 times 7 divided by 5 miles. Now, this is the same as 15 over 1. So I can cross these out, and 5 divided by 5 is 1, 15 divided by 5 is 3, and I get my distance being 21 miles. All right, now I know that when I originally did this work, I said that my distances were equal because it's the same distance from the house to the store as it is from the store back to the house. So let's check and make sure that's correct. By the way, this is in miles. Always give me your units. Okay, so my green D still has to equal rate times time, yes? I hope so. So I want to know what it is. My rate, according to my first chart, was 35, and this is miles per hour. And my time was 3/5 of an hour, a little bit over half an hour. So let's find my distance. My rate is 35, and I'm going to multiply it by 3/5, and distance is 21, again in miles. Do my distances equal each other? Yes, my computations are solid. So this is how to solve a round trip travel problem. Set your distances equal to each other and then solve one t in terms of the other.